Okay, so I'm making this video to illustrate how to run a repeated measures ANOVA or ANCOVA or a mixed ANOVA. So I know that sounds like a lot, but we run all of these tests using the same basic steps and the outputs look very similar. So I'm just going to talk you through this today. So first step, what are our data? So our data are derived from the Effort Expenditure for Reward task by Michael Treadway and colleagues. This is a reward-based decision-making task in which participants must choose between doing an easy and a hard version of the task. So that's the dependent variable that we're interested in, whether they've chosen the hard task or the easy task. The independent variable, so what's manipulated, is the level of probability, so the likelihood that they will win a reward, so an amount of money, if they complete the task in the given amount of time. So this probability value has three levels. So it's an IV with three levels. The levels are 12%, 50%, and 88%. Okay, so with a within subjects variable, you will have one column for each level of the independent variable. Under each of these columns, so the data in these columns are the average choice that the participant made at each level. So on average, when there was a 12% chance of winning a reward, this participant mostly chose easy tasks. Easy is coded 1, hard is coded 2. So 1.17 is the average value from all of the 1s and 2s that we added up and divided by however many trials they did. Okay, so that's the data that's under these columns. We've also got a between subjects variable, so handedness, and right-handed is coded 1, left-handed is coded 2. So here we see some participants are right-handed, some participants are left-handed. Over here we've got the percentage of trials that each participant completed. So you can see that that's a continuous variable, so it's like a number line, and it runs between, we've got 27 here up to 100. So yeah, participants completed a differing or various numbers of trials. Okay, so those are the data. Before you run any type of statistical test, you should of course check the assumptions for that test. Look at your Prada handbooks, look at your stats books in order to check that you've done this. I'm not going to run through that with you in this video. What I am going to do is do the test. So we're going to run straight to the ANOVA. So we go to Analyze, and we go to General Linear Model, which is where most of your ANOVAs live. We go to Repeated Measures. So you go to Repeated Measures irrespective of whether you have a mixed model, an ANCOVA, an ANOVA, Repeated Measures ANOVA, whatever it is, you go to Mixed Repeated Measures. Okay, so here we need to tell SPSS what our within subjects factor is, and that's probability. Okay, so all participants experienced all three levels of probability. So it's probability with three levels, and we click Add. And then we don't need to do anything else with this screen. We go to Define. And you'll see here, SPSS is asking us, tell me a little bit about this within subjects variable. You said it's probability. You said it's got three levels. Where can I find the data for these three levels? So we know that the data are 12, 50, and 88. Okay, so we've just popped that in here. Here, SPSS offers you the option to tell it if you've got a between subjects factor, so a factor that differs between the participants. And we know that that's handedness, so we've got different groups depending on whether they're right-handed or left-handed. Down here for your ANCOVA, oh, I should say that the within subjects factor makes it a repeated measures ANOVA. If you've got a within plus a between, it's a mixed ANOVA. If you've got a covariate, it makes it an ANCOVA. So here the covariates box offers you the opportunity to include a continuous variable. So this might be a questionnaire measure, so the Beck Depression Inventory, or maybe a measure of extroversion. In this case, we're going to pop in the completion rate. Okay, so how how the percentage of trials that participants have completed. Over here on the right hand side, we've got lots of different options that we can request more information or do more fancy contrasts and stuff. We're not going to do any of these ones today. What we are going to do is click on options. Oh, sorry, there's a cat beside me who's purring and growling. So we're going to click on descriptive statistics, estimates of effect size, homogeneity tests, and that's it. And you leave everything else as it is and click continue. Then we'll click OK. And we should get an output, which SPSS has chosen to hide from me. Oh, it's just taking its time. Hopefully won't crash as it did in the first 3 versions of this video. Great. Okay, so let's find that output. Great. So here you can see that you've got quite a lot of output. The first 2 boxes up here just tell you again what your within and between subjects factors are. So probability with 3 levels and the data in those levels. So it specifies that these data are your dependent variable. And your between subjects factor, which is handedness, and how many participants are in each of the 2 groups. So you can see we've got very uneven groups here. You've got some descriptive statistics with the means and standard deviations for most of your variables. And remember, it's really important that you report these descriptive statistics for all of the variables in your study in your report. We're going to scroll past all of these and we're going to go straight to something called Mauchly's test of sphericity. Mauchly's test of sphericity is one of the key assumptions of the within subjects ANOVA. So wherever you have a within subjects factor, you are going to need to check whether or not there's sphericity. So whether the 3 or more levels of the within subjects factor can be compared to one another in terms of the variance or the spread of scores in each factor. Mauchly's test tests the null hypothesis that there is sphericity. Okay, so the null hypothesis is assume sphericity. So that means that ideally you want a significance value that's greater than 0.05. So you want a non-significant Mauchly's test in order to say that there is sphericity between all 3 levels of the independent variable, of the within subjects variable, sorry. In this case, as you can see, Mauchly's test is significant. This isn't super unusual, and it's also not that big a deal. It just means that we read the statistics off a different line. So we go down here to our test of within subjects effects. So this has tested the within subjects variable and looks to see if there are main and interaction effects for that variable. If Mauchly's test were non-significant, you would assume sphericity and read off the line that says sphericity assumed. If Mauchly's test is significant, as is the case for us, we cannot assume sphericity, so we can't read off that line. Instead, we have to look at one of these other lines. And these other lines apply a correction to the maths behind calculating a within subjects effect to allow for the fact that there's no sphericity, or that sphericity has been violated in the data. I'm going to recommend that you look at the greenhouse geyser correction. The reason I'm doing that is because it's the most conservative, so it's the strictest of the corrections that SPSS gives you. So we know we have a significant Mauchly's. We know that that means we read off the greenhouse geyser line. So we go hurrah, we have a significant main effect of probability. Okay, so this top box tells us that we have a main, tells us the information about probability. Whether there's a main effect, we see that we have significance. Great. The next box here tells us about the interaction between probability and completion rate. Okay, so whether the level of likelihood of getting a reward interacts with how many trials the participant has completed. And intuitively, we would think that it probably does. Again, we know that we cannot assume sphericity in the probability variable, so we read off the greenhouse geyser line. Again, we have a significant effect. Great. Down here, we're looking at the interaction between probability and whether people are left-handed or right-handed. Again, we're reading off the greenhouse geyser line, 0.041, so we have a statistically significant effect there. It's less than 0.05. Okay, so all three effects that we've tested here are significant. Great. In terms of what you need to write up then, as with all ANOVAs, you write up your F value. So F is equal to 16.87. Found it really hard to distinguish those numbers. So you're going to have F and in brackets your degrees of freedom, which here are 1.674 and 71 point something. So remember, you read a degree of freedom from the tested within subjects effects and from the error degrees of freedom down here. So this is where you get your second degree of freedom. You say that it's equal to your F value, and then you tell me what your significance value is. So P is less than 0.001 in this instance, and P is equal to 0.033 in this instance. Over here, we've got our partial out of square, so our effect sizes, so you should also report those. I have no idea why my lights have just went crazy. So over here, you have your partial out of squared, your effect size, so you repeat those, and you should interpret those as well in light of how important or not important, so how large or small the effect is. Okay, moving on. So we've looked at our within subjects effects and interactions. We're now going to look at our between subjects effects. So this is the influence of handedness and also our ANCOVA, so whether or not there's a significant effect of our covariate. So we'll move down here. Our between subjects effects is in this box down here. So the first thing it shows us is the completion rate, and we can see that that is significant. Okay, so there's a significant influence of how many there's a significant difference on whether participants complete the easy task or the hard task, depending on how many trials they've completed. Sorry, I briefly lost my train of thought. And then we have no main effective handedness. So it's irrespective of whether participants are left-handed or right-handed, it makes no significant difference on whether they choose the hard task or the easy task. Okay, and you can see that echoed in this tiny effect size here. Yes, and again, so we've got our effect sizes over here, and you should report and interpret those as well. Okay, so I hope that makes sense. That's basically an ANCOVA, a mixed measures ANOVA, and a repeated measures ANOVA, all condensed into one. If you have any questions, just get in touch with me.